Welcome to the HiRSE Seminar Series on Research Software Engineering in Helmholtz and beyond.
So, hi everyone. Thanks for the introduction and thanks to everyone for joining today. So today, Mustafa and I want to talk about two tools that we recently developed, which are for deploying tools that help with fairness and sustainability in research software development. So let's get started. As a little motivation, I start with a few quoted slides. So I think in this audience, I don't have to convince anyone that software is important for research. And the number on the right is the one we care about the most for this talk, that like over half of researchers need to develop their own software. And well, research software can be classified in various classes, and there is a classification developed by the DLR. And in our work right now that we present here, we focus on the ones that are basically developed by software that started as a bachelor, master, or PhD thesis and maybe grew over time and might have become a community code. And suddenly people depend on it. Because if you just have a code that you just wrote for a figure in a publication, it might be not a problem. You don't have to really think about software development and practices and things like that when you do that. But on the other extreme, you have complex mission critical software that's usually not developed by researchers, but rather by specialized departments or external companies. So what we care about is this middle ground, all these softwares that grow naturally, organically in the scientific work by domain scientists or RSEs or scientists who turned developers. And we want to make sure that the software also is sustainable and maintained and usable 10 years from now. So another nice slide I quote here from a talk in the last RSE conference shows here the long tail of science. And here you can see like most projects have basically one main developer. So the so-called bus factor is one. When a person is gone or ridden over by a bus, then the software is basically dead. Nobody can take over. There is no one that can maintain or understand it. And usually these software projects just stop. They stop and in the future, nobody can use them. And this is a problem because we want to have reproducible, sustainable research software that can last, that can be used years from now. And if you want to have that, well, I think everyone with a software engineering background will say that this is kind of common sense. Just follow best or good practice for software development. But the problem is the majority in the academic environment probably just doesn't know, and how can they know what a good practice in software development can be? So this is what the first tool we want to present here is concerned with. We want to basically help spreading and deploying best practices to researchers and research software engineers and help them with that. So imagine some researcher comes to you and they want to write some tool in Python. Python is the most popular language in science, and they've heard about the FAIR principles and they would like to do a good job. They want others to use it, maybe attract some contributors and have the software have a good quality so others are not repelled by it. So they ask you, what should I do? How can I do this right? And you would like to say, well, it's easy. You just do A, B, and C, and you can put some file X, Y, and Z in your project, and then it's fine. You can get a FAIR stamp on it and everything's good. But this is sadly not the reality. It's actually quite a difficult task. So to run a software project of like some non-trivial size, so then you have to think about a lot of things that you might have never heard of before. And there is an overwhelming number of different concepts you need to understand, tools you need to combine, and recommendations you might want to consult or consider. So it's a hard job. And it's actually requires a lot of knowledge and expertise. So because software development is much more than just programming. Most people pick up programming somehow during the job and write their codes, but running a long-lasting software project in a good way, this is basically a completely different game. So to set this up properly, you need to take some big and small decisions in many places and set the stage correctly in the beginning, combine various technologies. And of course, you can do all that. Everyone can learn many things if they have a lot of time and motivation to do it. But let's be real. Imagine a domain scientist and who's busy with their main task of doing research. And do you think they have the motivation, spare time, and experience to learn about all these things and get an informed opinion about it and also feel confident in their choices? Of course not. So let's summarize this. Most tools, or like many tools in research, are created by researchers because they know what they need and they create it for their own work. On the other hand, these tools are not their main job. These are just tools to do their job, which is producing novel knowledge because they're doing research. Their job is not writing software. And I personally believe we cannot and should not expect that researchers want or even like should turn into software developers, because that's not their qualification. That's not what they sign up for. Of course, the perfect solution would be hire more software developers, but we all know how difficult this is. There is maybe change coming, but it takes time. But what can we do now? How can we help to improve the situation, help to spread best practices, and make sure that software created now will be fair and sustainable? So I believe, and we agreed on this when we created these tools, that we should just try to lower the bar as much as possible and make doing it right as easy as possible to the researchers. So remove this overwhelmed complexity of navigating all these topics that you need to understand. So the idea was, well, why not provide to the community a template that can be used and shows that how it can be done. So it basically already, by putting in our work, we are software developers who can navigate all this and have some experience, and we can set it all up. But by providing this to the researcher, they have already some solid foundation to start from and learn as they go as much as needed, and are not overwhelmed by all the choices they would have to do and all the knowledge that would need to be acquired. So to make this also even more useful, this thing should be well documented. So basically helping the researcher to make this repository their own, because of course everyone or many have been in a situation getting some complex repository or code base and navigating it. It can be hard. So of course, good documentation is important. And here we're also kind of trying to lead by example. This template is well documented. We want people to be able to understand why is it the way it is and how you can change it. So the idea is, if the researcher comes to you and asks how to create a fair or like high quality software tool, then you might still not be able to tell them like follow these 3 easy steps, but at least you might be able to point them to this template and tell them maybe this helps you getting started and gives you some ideas that you can use in your project. So what is this template? So the fair Python cookie cutter template is a generic, so it's domain agnostic Python template, and it's directly usable. So when you start from scratch, you can just create a new repository starting from this template and get started with implementing your tool or library or whatever you're doing. And while creating it, we wanted to do like everything as right as possible. So we consulted various recommendations and integrated them as much as possible in the setup. So basically implementing both like recommendations outside of the scientific environment, the open SSF best practice checklist, which is also respected in the industry, or also the recommendations for software development by the DLR, which is more close to the academic environment, or the Fair Software EU suggestions for what the minimum requirements for a fair software project should be. And also the Helmholtz metadata collaboration itself, which also has certain suggestions and documents how you should basically make sure that your data and software is fair and has good metadata. So the idea is that we want to save researchers time when starting with a new project and basically enable them to get to their job and not be slowed down by all this steep learning curves that you need to basically get on top before you can actually do your job. So our template combines many tools for Python development, and we try to cover all the important bases. So we have covered basically the normal development cycle, dependency management, versioning, testing, and continuous integration, and also releases. So we suggest ways how you can do all these things and documented them so people can understand how to use this with this template repository. And we provide a suggested structure for a project landing page, which can be deployed and show also the sections that should be filled with live, and for user documentation, developer and contributor documentation, etc., etc. All these things that you might be not aware of or forget easily when you're not experienced with creating a software project. And we are the Helmholtz metadata collaboration, so we also especially care about metadata and believe you should also care a bit more about metadata, because it helps with the search engine optimization and to find your code and maybe get your software into a knowledge graph so others can also easily find it. So to help with that, we integrate a tool that we also developed, and Mustafa will talk about it a bit later. Somesy is a tool that also helps with organizing and managing and keeping the metadata of the software project consistent. So as mentioned, the template is also containing a lot of comments for all the configurations. So it's clear why the settings, what they do. And also when you want to change them, it points to other resources, to the documentation of the tools that we embedded in our template. So you can easier understand how to change it to your liking. Because of course, everyone's requirements are different, and it's clear that many people maybe don't want to use all of this as it is. We try to make it as easy as possible to make it suitable for your purpose, or at least reuse pieces of it. So this is kind of a living, hands-on educational resource, as well as it is a template repository you can just use. So to give you the practical overview of what you get here, when you install the Fair Python cookie cutter tool, which you can get with pip, you will be asked a bunch of questions. And that can be also look a bit intimidating, but we try to ensure that as much as possible is filled out for you automatically. So we suggest that you already create an empty repository and provide the URL as the first response, and then the tool can infer a lot of information just based on it. So here we already can see that the tool can infer the project name, and it can also infer the hosting service, which is like the Helmholtz GitLab instance and other things. So it asks you also about general information for you in your project and about yourself and your affiliation. So you can see at the bottom, it gets my name, email, and ORCID. And you see I didn't have to enter them here. It loaded them from the settings, because at the end of the questionnaire, you have the option to save all the general information for reuse. So basically, in the next time, you just need to enter a fraction of the fields that we asked the first time. Again, in the red box, I just pressed enter. It's all automatically filled out. Unless you have some very esoteric setup, this should be basically already done for you. And in the end, you have the option to initialize some example code. And for example, you want to create a command line tool, you can get a little skeleton for that. Or maybe not the typical researcher use case, a little web API. We're open to suggestions what kind of other example codes might be useful, which you could add here, maybe for some figure plotting, I don't know. But if you say no to these, you just get the raw skeleton and can just put your own code in there. And in the end, you can, if you want, save these general settings like your personal information in a settings file, so next time you don't have to enter them again. Yep, and after that, what you get is this nice directory. So this is the top level directory. This is a screenshot from the GitHub version. So you have a bunch of files, a bunch of folders with even more files. And what's important, that to understand these files, we include a developer guide, which you can see. It's a little document included in the project documentation of the resulting repository, which explains basically everything you can find in there. What it is, why is it there, how you can change it, or how to enable it. So certain things like deploying your website needs some setting up, or the releases to Python package indexes needs some setting up to do. Depending how you do it, you need to also consult the developer guide, which you can keep around as a resource also for future contributors who might join your project, because then you already have everything explained. You don't have to write this documentation anymore, basically. On the left side, you can see a screenshot from the main page of this project website that is generated. And as mentioned, we have like two sections here. Usage is more targeting the end user. Development is more targeting contributors and developers and maintainers of the project. And you have a section for the changelog, which of course the authors, the maintainers need to fill also with content. And But you already have basically the structure containing all the content that you should think about when developing, maintaining, and continuing with the project. And here you can see how the pipelines that also we included in the template work both for GitHub and GitLab in similar ways. So they have exactly the same features. You can automatically get the tests run and the pages deployed to GitHub pages or GitLab pages if you have that feature in your GitLab instance. And you can publish your project when you have a release tag you attach. Automatically it can push it to the PyPy or other package indexes. If you have some private ones you want to push it to, you can configure them as well. So you can see all of this that I've shown you here. There is also another repository, which is called FairPython Cookie Cutter Demo, where you can just browse a bit which files would be generated and see how the page would look like and all these things if you want to get an idea before you install and try it yourself. So this is the template. And now I will give over to Mustafa, and he will tell you more about this somesy tool to clean up the metadata files and manage them for you.
Hello everyone, this is Mustafa and I will be presenting the second part on our tool somesy. So firstly, did you know you can do this in the GitHub repository? In a GitHub repository, in the right side, there is a pop-up that when you click, it shows cite this repository, and you can see we have our citation directly in either in APA or BibTeX format. So why did I show this? Because metadata matters. There are some community accepted metadata files which already has integrations with, for example, citation CFF. It has GitHub and Zenodo integration, and if we have this citation CFF file in our repository, GitHub will directly show that cite this repository button. And this, for example, this citation CFF file has a good human-machine readability, and it is usable for software and data sets. And another metadata file standard is code meta.json. Since it's based on linked data and graphs, it has good machine readability. And it is good for web crawlers, especially since it says linked data and, for example, some knowledge graph like ours, Hanait, or for SEO, it is really good to have this file. And we also have a language-specific file in our repository. It can be PyProject TOML if Python, or package.json if the JavaScript. So we all have this data. We should all have these three files at least in our repository to have a good metadata and have better accessibility to our repository and project. But they all have different formats. For example, PyProject TOML in top left has TOML format, or citation CFF in bottom left has YAML format, or as its name, code meta.json has JSON format. And all of them have same information, name, version, description, but for example, in citation, it's called name called title, or in code meta.json, it is not authors, but it's author. So there are these small changes everywhere, and it's so messy. This is why we called our project so messy too. And whenever we have a new version, whenever we have to change something in our metadata, in order to have this common same project version in the citation file, or for web crawlers, for web access, better web access, we would want to change all of our metadata files at the same time. But it's easy to forget because sometimes we hurry I don't know, we are doing a bug fix. We want to just release it and change it PyProject file and forget it in citation CFF. And if somebody is citing our project, then they will be citing the wrong version. And it is error prone, as we showed. They have different formats, different keys for the same thing. So it is time consuming to even check one by one which key was it. Uh, So this is why we created somesy. We have one single source of truth for all of these metadata files, and we avoid duplication of writing the same thing with our rich metadata, and we automate this metadata synchronization for these files. Some files has extra information, might have extra information. Some standards, for example, in PyProject TOML, there are lots of information about the uh, packages we use, libraries, or in citation CFF file, there might be more information than what we have in somesy for persons or organizations. And in order to save this extra information, we are using some magic algorithm uh, background especially for person merging, and we uh, keep existing information in the files. Also, what we want to do is have metadata easily, and for this we created a pre-commit hook using in somesy. A pre-commit hook is a program that runs before whenever you say git commit. Before committing your commit, it checks your files, changes, and check some things in there, maybe do some linting, formatting, or checks metadata like something. So if you add as a pre-commit hook, whenever you commit something, somesy will check if somesy will sync all the metadata, and you won't have to think about it again. And currently, we are supporting uh, PyProject TOML and package.json as language-specific file, but since due to its modular structure, this is extensible. Also, with our latest version, somesy is compatible with Windows, Ubuntu, and macOS. So in the left side, you can see an example input for somesy. There's project metadata, people in the project, and some other configuration settings. We read this information from either a TOML file called somesy.toml, or you can embed it into your PyProject TOML and or package.json. So when you have this, somesy will read it and uh, update, synchronize the data in the target format. So in order to show it a little better, I will do a demo for Fair, Python, Quickcutter, and somesy. So let's create a project with Fair, Python, Quickcutter. So as Anton said, we suggest you create an empty repository beforehand. I created this HiRSE Seminar repository in my GitHub, and let's enter. Since we already entered our project repository, project name is parsed from this URL, and let's add a description. Let's say a test project for Fair, Python, Cookie Cutter, and somesy with S, somesy, and keywords. Let's say Fair, Python, somesy, and project version. This is okay. Here is okay. MIT is okay for us. So as Anton said, in last time I used it, I saved my data. So it is showing my name, last name, first name, email, ORCID, and my long affiliation, which I only want to enter one time. Thank you, Anton, for that. And from now on, it uses the URL to detect its project host or GitHub related or GitLab related stuff. If you don't have a different setup, just entering here is enough. And let's add both CLI and API example code. So since I saved my data last time, I will say no to this, but if you say yes, then it will save your personal data in your computer, so you won't have to enter the same things again and again. Just enter things and it will be ready. So now it is creating our new repository. And since we have some pre-commit hooks already installed, added in the Python cookie cutter, it is installing and creating all of the files. Okay. Okay. And it's creating our documentation files too. Okay, now we created our new project. So I opened this project in Visual Studio Code. So in the left side, you can see uh, our files. As Anton said, we have GitHub and GitLab CIs files for that. You know, if you don't want to use some parts or if you want to change some parts, you can just edit it here or just delete it. Also, we have example code here for example, for a FAST API examples, and of course, all code should have tests. So we have example tests for that too. And we have our PyProject TOML file here. In our PyProject TOML file, we have this dictionary part called tool somesy, and the project part gives somesy project input. So we have the project name, version, description, created by Python cookie cutter, and me as the only author and maintainer of the project. From this code meta.json file here and citation CFF file is created by somesy. Somesy, sorry. So let's play a little with somesy, and let's say change version to 0.1.1. I will add this to stage area and commit. Let's say bump version to version 0.1.1. So when I commit this, pre-commit hooks will work. And in pre-commit hooks, there are some linting, formatting, or type checking. You can, of course, check them and delete the ones you don't want to use. In here, our commit failed because somesy failed because our data was not synced. So somesy here synced, found PyProject YAML file, and it is poetry based, so it synced that. Then it found citation CFF file, synced that, and it found code meta. It created code meta JSON too, and it is here. We can see here. Let me get this down. We can see here directly citation CFF is synced, code meta version change. Also, PyProject has poetry. Since it is a poetry based tool, it has poetry metadata too. So poetry metadata is changed too. Okay, now we have other changes. Let's say git add again and git commit and bump version to 1.1.0.1.1. Okay. Oh, I forgot to close the code. Okay. This time, somesy of course didn't failed since everything is synced, so we could commit it without problem, and everything is synced. So let's try something else. So if you remember, we said we do some magic with human person merging. Let's add some person first before that. Okay, I am the only author, but let's add another author here. He will be just author. Let's call John Doe. And Doe, and give him a proper ORCID with 1, 2, 3, 4, 5, 6, 7, 8, 9. And in our somesy input, we added another person as author with its metadata, and let's add it. Git add and git commit add John as a new author. You can see here, since we have new metadata, somesy failed again and synced our data. So from here we can see what changed. Citation CFF got updated by this information in its own format. Of course, code meta has John Doe in authors and contributors, since every author is a contributor. Also, in here we get John Doe in poetry author format too. So our metadata is synced. Let's say git add again and commit. And this time it passed without any problems. So finally, let me show you this human merging stuff works. Authors, I don't know if anyone uses it anymore, but let's add facts. 3, say this, I don't even know. And let's pump our version to, or let's add the keyword to, say cookie cutter. Okay, we added facts to citation CFF part, and we changed version. Let's see when somesy sync things, if our facts information or additional information is saved, preserved. Let's say git add and git commit. Let's say pump version to 0.1.2. Okay. In here, of course, again, you see our keyword is added, citation CFF, and facts is not overwritten because we are checking and finding the person and preserving the extra data here. And also, of course, we have our new keyword in every other files. And we can say git add again and commit. Okay. With this, our small live demo ends. We are open to questions, I think.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below and see you next time.